We are a supply chain intelligence company. So we determine market pricing for a range of commodities associated with electric vehicles. We also forecast these into the future, and we offer sustainability consulting as well. I am part of the pricing team, and I cover graphite and lithium. And thus, I'll be speaking to you about Anode today. Right. So, just to give an overview of the synthetic market, we cover a range of anode chemistries at Benchmark, and including graphite, graphite silicon, MCMB, and a range of others. But despite the variety, natural and synthetic graphite dominate the market. In 2024, they accounted for 95% of the total anode active material market, and it's expected to maintain that market share to 2040. A trend that is emerging, however, is that the share between synthetic and natural anode is changing. We're seeing a high proportion of synthetic anode material taking over the market. Synthetic graphite AAM capacity has ramped up 626% between 2018 and 2024, and market share has grown by 10% since 2018. So it's taking away market share from natural anode material. So this asks two questions then. What has driven the expansion of synthetic graphite AAM market share? And what place do alternative chemistries have in the current and future market? Focusing on what has driven this expansion, there's a couple of market and external factors that have primarily driven this expansion. These include supply availability, affordability, and improved ESG. Focusing on supply availability, this has predominantly been driven by overcapacity in China. Synthetic AM supply globally is set to rise 156% over the next decade, so significant growth. And this will still be driven by Chinese incumbents. So natural AM, China dominates the market, and particularly for synthetic AM, they have significant overcapacity and they dominate the market. But despite this overcapacity in China and strong supply picture, synthetic AM supply is still expected to grow massively in China in the coming decade. We are expecting 156% rise to 2034, and a 19% compound annual growth rate. And so, despite synthetic anode dropping its market share, increasing its market share massively between 2018 and 2024, it's expected to maintain that. This has led to a supply side surplus. So due to this massive expansion, we see a significant surplus in the market for synthetic anode material. And this kind of capacity in the market and the ability to respond to demand has meant that producers are choosing synthetic anode material over natural because of this just ample supply in China, where most of the anode material is produced. Looking to affordability, this is very key, as often we find for EV cells that producers try to cut costs in the anode part of the cell. And this is another trend that has supported synthetic. So high capacity is still more expensive than synthetic, although the gap has narrowed massively. But what we've seen is that producers are increasingly using medium capacity active anode material. And the price for synthetic actually fell below natural for the first time fairly recently. So this was traditionally a portables market, but we're now seeing it used in kind of smaller electric vehicles as well. So this kind of fall in prices has led to synthetic anode material occupying a greater market share from natural. Another thing that has happened when there's overcapacity is that we see market participants looking at methods to cut reduction costs. And so one of these ways is vertical integration. So in response to accelerated oversupply, we saw that producers are trying to onboard this vertical integration step to onshore some of those costs. This is particularly the case for higher tiered, more established producers. And this is primarily driven by a trend in 2022 when there was a capacity bottleneck in third-party graphite